Okay, this is going to be a video on some of the trigonometry in C3. I thought I'd go through something step by step to prove something, some of the identities, and I'll show you how to get there. So this, if you imagine each of the triangles as being congruent, is a proof for the Pythagorean theorem, primarily a squared plus b squared equals c squared. So here, each of these triangles have the sides C, B, and A. If you have this side B, this whole line, and then subtract A, then this length of a line, or the length of the square, is going to be B minus A. So you've got that each of these sides being C, and it creates a square. So you have C squared equals, then you've got the inside square, which is B minus A squared, and then you've got to add the areas of these four triangles. So it's going to be plus 4 times half base times height, so it's going to be B times A divided by 2, so half B A. So then you get C squared equals, then using the binomial expansion, B squared minus 2AB plus A squared, plus, then that cancels with that to get 2AB again, or 2BA is the same thing, then these will cancel, and you get C squared equals A squared plus B squared. So that's a proof of the Pythagorean theorem, which I'm about to use to prove that sine squared plus cosine squared equals 1. From the definitions of sine and cos, if you have a right angled triangle, then this is the opposite side, with that being theta. That's the opposite side, this is the adjacent side, and this is the hypotenuse. So the definition of sine, you might remember from SOHCAHTOA, is the opposite side over the hypotenuse. With cosine, it's the adjacent over the hypotenuse, and at the moment that's all we need to know. We don't care about tan for this proof. So sine squared is going to equal the opposite squared over the hypotenuse squared. Cosine squared is equal to the adjacent side squared over the hypotenuse squared. And if we add them together, we get O squared, so sine squared plus cosine squared equals the opposite squared over the hypotenuse squared plus the adjacent squared over the hypotenuse squared. So O squared plus A squared, and then we can put them together because they've got the same denominator. And from Pythagorean theorem, the opposite squared plus the adjacent squared is equal to the hypotenuse squared. So then we get the hypotenuse squared over the hypotenuse squared, which is equal to 1. So that is the proof of sine squared plus cosine squared equals 1. And it's one of the proofs. There are lots. Same with the Pythagorean theorem. There are loads of proofs. I think I found a website and it gives you 99 different proofs. I'll put that in the description of the video. So now what I'm going to prove, is, which is actually the thing in C3, are some identities using cot, cosec, and sec. So the first one, the way to derive them is by simply writing out the thing that we just proved, that sine squared theta plus cosine squared theta is equal, or identical really, to 1. Then if we divide everything through by sine squared, we have sine squared theta over sine squared theta plus cosine squared theta over sine squared theta is identical to 1 over sine squared theta. So this is equal to 1 plus cos over sine is cot, or the 1 over tan. So we have cot, but because both sides of the numerator and denominator are squared, it's cot squared theta. And this is identical to 1 over sine, which is cosec squared. So cosec do the same thing with cosine. So if we just get rid of that, we can write it out again. So sine squared theta plus cosine squared theta is identical to 1. Divide everything by cosine squared theta now. Sine over cos is tan, so you get tan squared theta, and cos squared over cos squared is just going to be 1, is equal to 1 over cos, which is sec squared. So this is our second identity. So I believe these are the only two that you need to know in C3, and we'll just write them out again at the top, and then I'll do an example using them. So we have 1 plus tan squared theta is equal to sec squared theta, and 1 plus cosec, cot squared theta is equal to cosec squared theta. So the example that I've got, which came out the EdXL C3 book, is that we're trying to prove, or it says show that cosec squared x minus sine squared x is identical to cot squared x plus cos squared x. First thing we do is rewrite cosec squared, so you get 1 plus cot squared minus sine squared x. So this is the way I write it out is you say left hand side. I always start with the left hand side, I don't know why. But you have left hand side is equal to 1 plus, or cosec squared x minus sine squared x, which is equal to 1 plus cot x minus sine squared x, which is equal to 1 minus sine squared x plus cot squared x, which is equal to, or 1 minus sine squared from sine squared plus cosine squared being identical to 1. You subtract sine squared from both sides, you just get cosine squared. So that's going to be cosine squared x plus cot squared x, which is